For our next video, we're going to go over a similar concept that we've done before, which is angular momentum, and then we'll also talk about practice problem number 25. So we'll just start out by reviewing what angular momentum is. Here's the equation: L equals R cross P. So what we have to remember about this is P is momentum, linear momentum, so that is equal to m times v, where v is linear velocity, and that'll come up handy in the problem. So now we're just gonna go straight to the problem because it's pretty straightforward and simple. So we'll read it again. It's the second part of a three-part problem. So, two satellites of masses m1 and m2 orbit a planet of mass m in circular orbits. The satellites travel in opposite directions with speed v1 and v2, as shown in the figure above. Their orbital radii are r1 and r2 respectively. Assume that m is greater than m2, which is greater than m1. So, now we're going to read our section of the problem, which is the magnitude of the angular momentum of the two satellite system is best represented by. So to do this, all we have to do is think, okay, angular momentum, and think about what do they give us. So they tell us that the inside orbit has a mass m1 and the outside orbit has mass m2. And they tell us their velocities, which are in opposite directions. So the velocities are, for m1 it's v1, and for m2 it's a v2. And what we want to remember is m times v equals momentum. So we already have the linear momentum aspect of the angular momentum. All we need is now the radius. So now we look, what do they give us for radius? And they tell us, so for m2 it has a radius of r2, and for m1 it has a radius of r1. So we can write that right here. We can write L equals here. We can write r1 and r2. So we can write that equals L and equals L. So that is for m1, here's our linear momentum, and for the outside orbiting planet here is r2. So now what we're going to do is we're going to look and see that the problem asks specifically for the magnitude of angular momentum. So what we have to think about here is that it's not just about how large the magnitudes are, and not about in which direction the the satellites are going. So we can look at this. So even though that m1 is going in a completely opposite direction of m2, that doesn't matter. All that they're asking is the magnitude, so that means that we're gonna have a absolute value in the answer. So we look through them and all of them have an absolute value, but now we know we have to add the angular momentum of both. So all we do is add both angular momentums and then take the absolute value. And as we look through the answer key, the only one that adds angular momentum of both is answer C, and that's our correct answer.